Now today's class, we are going to see that CBQs of from electricity chapter. So this is one of the most important, and here only you will find many new questions also. So let us see what is that and how to solve. So if you go to the first question, you can see. So read the information given below and answer the 4 out of 5 following questions. So that is the first thing they are saying. So these questions, some are very easy, but some are very, very tough. But there is no too much of hard question. So if you are good in basic concepts, definitely you can solve it very easily. So let us see first they are saying, Suresh bought a packet of 100 LEDs to make his own light for decoration in his house. The packet on the LEDs had the following printed on a label. That is what? LED 2835, 0.2 watt, 30 lumens. That is what? Luminous. The intensity of light and 3 voltage. So is it belongs to the all 100 LEDs or each one LED? Anybody? Yes, please. One LED. So this is the characteristics of one LED. So LED number is LED 2835. Power is 0.2 watt. Voltage is 3 volts. Luminous intensity of light I is 30 lumens. To understand how he should connect the LEDs, he referred the following circuit diagram on a website. So we all know that LEDs, they will consume low power. So we have to connect them in series connection or parallel connection. LEDs, you all can see LED sets in our daily life. So LED set will be in series connection or parallel connection. LEDs low power. So always they have to connect in what connection? Series connection. So you cannot make every LEDs individual switch, individual connection. So we have to connect them in what connection? Series connection. So now if you have seen here, this is how the main supply LED 1, LED 2, so on, LED 8. After that, LED 9, LED 16. So finally has been referred this circuit. Now they are asking, which of the following describes how the LEDs are connected in the circuit diagram? So how the LEDs are connected in the circuit diagram? Anybody? Color connected in what connection? Continuation, you can check it. What connection it is? Parallel, series. Everybody?
Series connection.
All are in series connection. That is what you have to remember. Clear everyone? Everybody? Yes, please. Next. So if the LED marked LED 2 in the diagram stops working, which other LEDs will also stop working? Anybody? Series connection, you have to remember one point. Any one of you? If any one device will stop or if one device will damage in the during connections, then what will happen to other devices? Every device will shut down. Am I right, everyone? All of you? Because if the LED2 will become, LED2 is damaged, means in the sense of entire circuit diagram become open circuit or closed circuit. It will become open circuit. So if it will become open circuit means what happened to other LEDs? All the other LEDs will not glow. So that is the reason if you have choose LED series, if one bulb is damaged, then automatically all the other LEDs before and as well as after everything will be shut down. So what is the answer? Anybody? All the other LEDs in the circuit will not function. So why even they are giving here? When an LED stops working, current cannot flow across it. So they are in series connection. If they are in series connection, suppose if this resistor is damaged, understanding that bulb is damaged, then what will happen? No current will pass through it. So the no current will reaches to them also, because we all knows that in series connection current remains. Series connection current remains what? Everyone? Remains constant. That is what you have to remember. Okay, everybody? Please respond, guys. Are you clear? Hurry. So, yes, that is what. Next, Suresh decided to connect all the LEDs in his lights in a series combination. Very good. Nice. Wonderful. Now, how many LEDs will he need to connect if he is going to connect the lights to a 240 volts main supply so that LEDs work at their power rating? Anybody answer? How many LEDs you have to connect them for 240 voltage so that the LEDs work at their power rating? Anybody can tell how to calculate at least? Here only last year we developed the formula. So that formula I am going to interlink now with the concept of exercise. There is a question. Do you all remember? Anybody tell me what is the expected question in exercise? So there is a question, calculate number of bulbs. 110 bulbs we got it. Do you remember anybody? Exercise question. We have got the number of bulbs connected in parallel connection is, I think, chapter number 9 or chapter number 10, Hari? Chapter number 11, correct? Electricity. Yeah. So if you have seen that, if you remember that sum, you are having NCERT book also. So that is the sum which will help us to study this. So there we can solve two methods. If you remember that, one method is to calculate the total resistance and individual resistance, and we have gone with that. Am I right, everybody? Or we have been done the power of a single bulb they have given. What is the power of a single bulb? Everybody. Several electric bulbs designed to use on a 220 volt electric supply line are rated 10 watt. How many lamps are being connected in parallel with each other across the two wires of 220 volts line if the maximum allowable current is 5 ampere? So we all knows that power P is equals to V into I. So power P is equals to V is 220 and I is what? 5. So we got the answer 220 into 5. How much is the answer? 220 into 5. Anybody? Which is equals to 1100 watt. This is the total power. So what is the power of a one bulb, everybody? Power of an individual bulb is 10 watt. So now we all knows that total power is equals to n times of individual power. So n is equals to total power divided by individual power. That is what 1100 divided by 10. 0 will get cancelled. 110 bulbs. You might be get this answer. Even I have taught you to find it also. Am I right, everybody? Yes, please respond, everybody. Clear? But here it is the parallel connection. So we all knows that parallel connection, something is remains constant. What is that, everyone? Potential difference remains constant in parallel connection. Yes or no? Involved in the class, otherwise we'll wind up the class. Are you clear, everybody? But if you have taken the series connection voltage remains constant or varies? Everybody? Series connection voltage remains constant or varies? Everyone? Varies. So, but that varies is equals to total resistance, total voltage. Am I right, Hasini? Varying resistance. So, voltage across this one, let me take V1. Voltage across this one, V2. Voltage across this one, V3. voltage across this one, V4. Am I right? Hurry, which is equals to total voltage. Yes or no? I'll take yes.
Yes, sir.
So now, here they are giving 240 volt is the total supplied voltage. Now, how many bulbs you can connect so that based upon their working power? That is the question. So anybody can answer. What is the expected answer? Anybody? It's very simple question.
80, sir.
Yes, 80. So here, please all of you note the formula. Here also, calculating n number of bulbs is equals to total voltage divided by individual voltage. So this is the formula. First time you might be heard. You might be not even knows. Nobody knows also because nowhere it is existed also. So total voltage is 240. Individual voltage on the pocket. Pakranga, what is the individual voltage? Everybody? What is the individual voltage? All of you.
3.
Understand? So 3 ones are 380s are. So what is the n is equals to everybody? 80.
8.
So we have to connect 80 lamps. 80 lamps, each one is having the supplied voltage is how much? Everybody. Each one is supplied voltage is how much? All of you. 3 volts. Understand? So which is equals to Vn. Each one is 3 volts. So 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus like that. 80 lamps it has been connected in series connection. So that which is equals to totally 240 volts. So that is why I said one of the most important. Last year only we have been formed this one. So from that. So please write it everybody. Make it clear, everybody. Understand? All of you?
Yes, sir.
Yes. Do it, Mr. Noor, Sanjay, Nimish, Google, Guru. Yeah. So make it. Anything doubt, you can ask me. So that is what you have to remember. Vitakshri. Okay, Abhirami. Next.
Yes, sir.
What will happen if he connects 100 LEDs all in a parallel combination to the 240 volts main supply? Anybody? What will happen? That is a question. Very simple question. Even I have taught you many times. My capacity is 3 volts. You are connected me everything in a parallel connection. Parallel connection, somebody remains constant. Yara, what is remains constant in parallel connection? Anybody?
Voltage.
What
Voltage.
remains constant? What is remains constant, everybody? Supplied voltage is remains constant. So now my actual capacity is 3 volts, but you are supplying the supplied voltage of how much volts? How much volts?
240 volts.
Means 80 times more than my required voltage. So what I will do? I will damage. I will blast. I will fuse. That's our answer. Do you understand it? Short circuit will take place. Very good. So what is the answer? Each LED will have the potential difference of 240, 240, 220 LED, 240, and therefore they will get damage. So why they have a same potential difference? Because it is a what connection? Question they mentioned. Parallel. So parallel connection means which is remains constant. All of you, potential differences remains constant or voltages remains constant. So the answer is option B, option 2. Till here, anyone having any doubt, you can ask me or else we'll proceed further. I hope you all clear. Mr. Hari Krishna, Arul, any doubt, you can ask. Gayatri, Hari Vignesh,
Yes, sir.
Hasin, make it quick.
Yes, sir.
Yeah. So do it fast. Mr. Swadhan and Jivitesh Reddy, again and again I'm saying, rename it and join with your number, allotted number. Arun Kailash also. It's not your own. You cannot do what you like. Otherwise, leave from the meeting. No issues. Next question. This is one of the most important question. So how much current is each LED expected to draw when used according to the ratings given in the label? So let me see who will solve this question. Anybody? According to the ratings given in the label. So try to solve, everybody. It's very simple. How much current will drawn? What is the current drawn? Individual it is. So let me see your answer, please. Answer, please. Very simple. Hurry. Very simple, but if you look, it's very tough. Can I answer? So what is the power of an individual bulb? By seeing a label, what is the power it's given? Speak. Power 0.2 watt. Am I right? Voltage is given 3 volts. Now they are asking current. Wrong answer. Yeah, very good. So they are asking current. So can you tell me PY, there is a relation for us which is known for us. First formula of power. Anybody? Mr. Jivitesh, I am going to remove you from the meeting. Nitish Krishna also. Okay, what is the answer? What is the power formula? Anyone? Yes, sir, is very good. Guru also, very good. Answer, others also tell me. What is that formulas? Nitish Krishna also, I am removing you. Because you are not there in the meeting, simply joining and listening. Nonsense. I don't want these idiots. Right? What is the power formula? Power P is equals to V into I. So they are asking I. That's all. So I is equals to P by V. So power is 0.2. Voltage is 3. So 0.2 divided by 3, I will write as a 3 divided by 30. Sorry, 2 divided by 30 into 10 if I multiply. So what will happen? Everybody has to do. If I am not getting response, you can leave from the meeting. I'm asking Mr. Aswin, everybody do it. Version doing so 2 divided by 30 means 1 divided by 15. 1 divided by 15 answer 0.066666 will come 0.067 amperes. What is the answer? 0.067 amperes. Option 1. Any doubt, anybody can ask. Do it, everybody. If you know the formulas, electricity is always very familiar. If you don't know the formula only, electricity is a big torture for us. So please go through that and make it. Any doubt, anybody can ask me. Make it quick. Love you. Completed. Harini, Johan. Mr. Aswin,
Yes, sir.
Gopal. Do it next. So we all knows that ammeter and voltmeter. So ammeter must be connected in what connection? Anybody? Ammeter must be connected in what connection? Series connector. Voltmeter must be connected in what connection? Parallel connection. Okay. So now the diagram below shows that Amita had connected a circuit to verify Ohm's law. So what is Ohm's law? V is directly proportional to I. So V by I is equals to remains constant. That constant only we used to call with what? Everybody? Resistance. So resistance of a given conductor remains constant. So now if you see here, so they have given Ohm's law circuit, everything is okay. So if you all notice, identify which of the device in the circuit is an ammeter. Justify your answer. Meter 1, meter 2, which is in ammeter, you have to identify. So ammeter means it must be in a what? Ammeter means it must be in a what? Yes? Series connection. So it must be in a series connection. So which is series with the resistor? Meter 2 or meter 1? You all should find fast. Meter 2 or meter 1? So you can check it. Meter 1 is parallel. Meter 1 is parallel with the resistor. And meter 2 is series connection with the resistor. So which is everybody? Series connection.
Meter 2.
Meter 2. So this is the ammeter. Write it. Because it is series connection. What is the reason? Because it is current in what connection? Series connection.
Series.
Next. Draw a circuit diagram with appropriate symbols for the circuit shown in the diagram above. So everybody you can draw it. So what we all know Ohm's law circuit. So rheostat symbol therima, ammeter, resistor, supplied voltage. Supplied voltage. I think current is passing from that side. Yeah, this is positive. So this is negative. Here is the positive. Okay. So positive and a negative terminal. And voltmeter. Voltmeter parallel series. Parallel. So you can connect up or down or whatever it is. So this is what is the circuit. So make sure everybody you have to draw it. So rheostat symbol is what? Two symbols for rheostat. One is either this or one is this. Your convenient, you can use anything. Do it fast. First one. Next. Amitabh forgot to put a switch in the circuit during the experiment. The wire labeled unknown resistor becomes hot. This is recently only I taught you. The resistivity of the material of the wire increases with the temperature. Do you remember, everybody? Resistivity remains constant, but resistivity also will be affected by only one parameter. What is the parameter which we studied? Many a times I mentioned
Temperature.
to you. That is what is the temperature. Book also it is clearly mentioned. So resistivity also has been affected by what, everybody? With the temperature. So where it is that? I think here. Yeah. So materials, yes, both the resistance and resistivity of the material vary with the temperature. Very, very important. So that's what they are saying. So draw two potential difference versus current graphs in the same diagram as expected by Amita, as based on the actual observations she would make. Anybody can tell? All of you? Actually, what is her expected one? Anyone? If she will put properly everything, proper key and all. See, circuit key is missing. She forgot to put the key. So what is the key? Key means what is a science language? Key means what? House key. Key means what? Plug key. Plug key means what? Switch. You understand it? So she forgot to put the switch. Switch is only ways to call it as a key. So what she is saying, switch is she forgot to put so that resistivity keep on increases. So we all knows that resistivity increases automatically. What will increase? Anyone?
Resistance.
Yes. Resistance also increases because resistance is equals to resistivity into L by A. So both will affect with the temperature. If temperature rises, so if she forgot to put the key, how the temperature rises? Anybody can tell? What is the reason behind? Hari? Abhinami? I have taught you also the reason. Domestic electric circuit, the reason I explained you. If you connect the negative terminal and positive terminal directly, middle the number of devices are less. So what will happen? Extremely high current will pass because it will create low resistance or high resistance. It will create, all of you, it will create low resistance. So automatically heat will increases. So here they are saying, as we know, during the experiment, the wire labeled unknown resistor becomes hot. The resistivity of the material of the wire increases with the temperature. Okay. Now draw two potential difference versus current graphs in the same diagram as expected by Amita. Actually, Amita is expecting what graph will come? VI graph. We all knows that. Ohm's law graph. What is the expected Ohm's law graph? Anybody? What is the expected Ohm's law graph? All of you. It is the linear graph. Am I right? Yes, please. So that is what is expecting. But based on the actual observation she would make. So what will happen, everybody? Temperature rises, so resistivity increases. Resistivity increases, resistance also what? Increases. But beginning it will be remain same. So up to certain point, the VI graph will be in a same path. But suddenly as the resistance rises, then because of resistivity increases, resistance also increases. Because temperature is increasing, it's become hot. Hot means definitely resistance rises. So the graph will become not linear, it will be a curved graph. So up to certain distance, it will be a straight line. After that, it will be keep on increases. So that is what is the actual observation, and what actually she has to get linear graph. But because of increasing temperature, the graph will come curved graph. That is what you have to remember. Okay, everybody? Understand, Mitakshri? Harish?
Yes, sir.
Yes. So please write it. Any doubt, anybody can ask me. So if she forgot to put the switch, what will happen? Continuously the current will start moving. So continuously current will goes without what is what. So it will creates, what will happen? The temperature is automatically increases more and more and more faster. So that is only leads to event. You can see immediately they will start burning. So many people you might be experiencing it. If you connect the negative and positive terminal of a battery, you see automatically battery will start fire. So that is the problem, because it will increases the heat more and more. So I hope clear, everybody. Any doubt, anybody can ask. So this is what a graph. Expected graph is always linear, Ohm's law. But if there is no proper connections, or if it is continuously operating the same circuit, so it will leads to like overheat. So overheat, like you can see, is the graph will goes high resistance. So it will be towards to the, that is what, and non-linear curve. So it will be towards to the V. So it is rising up. Resistance is rising up. That's all it is, nothing else. Next, answer the question based upon the electric circuit shown below. All the four bulbs are identical. What do you mean by word identical? By this time your mind should say identical. Identical. What do you mean by identical? Anybody?
Same places.
Yes. Same bulbs. Same bulbs means identical. Means their power is same, their resistance is same, and all the voltage, supplied voltage, whatever it is same. That is what is asking. So now, how does the voltage reading on voltmeter 1 compare with the voltage reading on voltmeter 2? That is what they are asking. So anybody can tell voltmeter 1 and voltmeter 2. Of course, first you see voltmeter 1 is for V1, voltmeter 2 is for V2. That is what bulb 2. So bulb 1 and bulb 2 both are in what connection? Anybody can tell? Bulb 1 and bulb 2 both are in what connection? In the parallel connection. So parallel connection, something is remains constant. What is that?
Potential difference.
Potential difference. So what is the answer for this? Anybody? Remains same. Okay. So, but is it equals to total potential difference? That is my question. Anybody? Is it equals to total potential difference? No. Because if you want to modify the circuit, I will modify. Is it right or wrong? Verify. Bulb 3. Okay. Next. Bulb 1. Next. Bulb 2. Next. Bulb 4. This is the circuit. Is it right? Verify it, everyone. Yes or wrong? Yes, all of you?
Yes.
Yes. So even you want put ammeter, you can put. So plus and minus. So ammeter. So this is the bulb 3. So across this some voltage. Let me take V1. and these both are in parallel. So that definitely across them, the voltage something will be there, but that voltage is remains constant. Then across this, there is another voltage, that is what V3. So V1 plus V2 plus V3, which is equals to total V. That is what is series connection. Right or wrong, everybody? Yes or no? All of you? So V1, V2, V3 is equals to V. So across the second bulb and first bulb, voltage is remains constant, but it is not equals to total voltage. Ellame understood? Yes or no? Because they are in
Yes,
what connection? Same. Because they both are in what connection? Parallel connection. That is what you have to remember. Next, identify the bulbs through which a current equal to the reading on the ammeter flows. Anybody? In which bulbs the current reading is remains same? Anyone?
3 and 4.
Yes.
3
and 4. Why? Why? Anyhow, identical.
Yes.
Let me take here current is I. Current is I means across the three bulb also, across the bulb 3, same current will pass. But across 1 and 2, can you tell me what is the current? Mitakshri, fastly. Anybody? Both are identical. So what is the current here? I by 2. Here what is the current? Here also I by 2. So again will come and they will combine across the bulb 4. What is the current will pass now? I by 2 plus I by 2, which is equals to I by 2 plus I by 2, which is equals to I. Do you understand, everyone? So in what will happen, everybody? So in which bulb the ammeter reading remains same? Series connection, because we all know series connection current remains.
Constant.
And remains constant. So by remembering that, bulb 3 and bulb 4, they both are in series connection. So current is remains constant. Clear, everybody? Yes, please. All of you? Very, very important this is. So why, sir, you are writing I by 2 and I by 2 here? Anybody tell? Because they are what? There is a word here. What they are? Identical. Yes? So that is what you have to remember. Do it fast. Make it quick, all of you. Hurry, take option is hurry. This Nitish Krishnan also put it nonsense fellow. That fellow not at all listening and not simply is cheating. Next, Suresh arranges the electric circuit shown below to measure the current flowing through and the potential difference of a bulb. So Suresh arranges the electric circuit shows below to measure the current flowing through and potential difference. He wants to calculate current. He wants to calculate the potential difference. First itself, by seeing circuit itself, he says, is it right or circuit? Wrong. Anybody? Wrong circuit. What is the mismatched one?
Wrong.
Here voltage should
Ammeter is
come
correct.
and here what should come? Ammeter should come. Because ammeter must be in what connection? Series connection.
Series.
Voltmeter must be in what connection? Parallel connection. Okay, that's all. So if not, then identify the mistake. Ammeter and voltmeter need to be modified. That is what you have to remember. Meeting is going to end. Join back. The question which we are going to get in 9 and next here to here, mainly this question, extremely important question. The very, very important question. Up to here, maximum will finish it today. Then remaining questions we'll discuss in our tomorrow's class. So I wanted this now. So anyhow, offline class also there. So question number 9. So join back fastly. We'll make it. So all of you, question number 8, understand? Modify the circuit and draw. And question number